Good afternoon. Thank you for your kind invitation to SOFiSTiK and to PSS. I am going to spend 30 minutes or 35 minutes speaking about our works related with BIM and SOFiSTiK, and also with a few lists of our works in Madrid, designing structures. The Riyadh Metro project, we have participated in several stations. We are going to see an overview. We are going to see how it works, the interdisciplinary workflow, and how works the workflow of structural engineering in making relations between different firms. Excuse me. Making relations in different between different firms, engineering firms. The overview is the civil works are in Riyadh. Oh, sorry. There are 6 lines. We are participating in the Orange 1 and line 3. There are 20 stations and 40 kilometers length, and we are designed E3, E4, E5. There's some really similar stations, and the way to work together with other teams are the composite. The final model is made by architectural models, made by others, is made with our structural models, made by CALTER, is made, with models made by others, film engineers, and finally, this is the composite model. And geographically, the communication is far, but it's not complicated. We work in that work. We worked with Bilbao, Madrid, and Bilbao, Madrid, because Bilbao was the map, and Madrid was structural matters. And also we work with Riyadh, is the final client. The 3D model begins with a Revit model. This is the images of the Revit, in one of the examples of the stations. And this is the interior of the indoors of the station. This is the Revit model. After we have an analytical model with the Revit. Perhaps it works, okay. This is the analytical model. And afterwards, it comes the loads into the analytical model, made with SOFiSTiK. These are the loads made with that. And finally, the calculation model, finally for the calculation steps, made with SOFiSTiK. And this is the typical image of a SOFiSTiK model of the station of other. This is this kind of a skin you see when you put in a model in SOFiSTiK. Finally, all the images of this is the head wall of the station. After the calculation model, we have to go back to the 3D model to make variations in the geometry, and we have now the concrete drawings is the geometry, final geometry of the model, and the sketches of the reinforcement we have to make manually to translate the reinforcement to the people is drawing the final drawings, the RC drawings, the reinforced concrete drawings. This is an example of reinforced concrete drawings, a detail. The Doha line underground is another project we have designed for the same geographical area in the Middle East. We have the 3 steps too. It's in Qatar. We work in the green line. There are 31 stations. We have worked in 6 evacuation shafts and 2 stations. Evacuation shafts is that kind of construction, and stations, 2 stations, Qatar National Library and Al Shaqab Station. The workflow is the same. Architectural models, there are a lot of models here. And there are structural models, a lot of structural models. Structural models even made by others. And map models, it's more complicated, this relationship, but and geographically also it's more complicated because we work. Okay, this is the composition of a model. This is the final model, but the model is made with all these models, specific models for specific parts. So they made the full model of the station and the emergency exits and so on. This is the final model. And the geographical relation is between Spain and Germany, France and Germany, UK and Germany, and finally Greece and Germany, and finally the Germany to Doha. This is the relationship is in a global world. It's possible. It's easy to work with that, and it's easy to work with that. We work in BIM because there are composite models you can change in real time. The 3D model is the same. In Autodesk Revit, we have, this is the analytical model, it's a mistake, sorry. This is the Revit model, images of the Revit model, and afterwards is becoming the analytical model with the Revit. Afterwards, the loads. The loads are coming, and okay, you put the loads in all the length of the station with the head walls and the ground actions and so on. And afterwards, the calculation model. We say in the office, it seems like a fish with the skin of the fish. The model of SOFiSTiK, that kind of typical model. The several views, the head walls. And finally, also with the 3D model, we build the concrete outline drawings. And this is the concrete outline drawings typically for one slab, with the definition of the dimension and the definitions of the names of the different beams and weights, lengths, etc. Other kinds of geometrical definition for the concrete drawings, outline drawings, and details. And afterwards, we make the sketches. To make the sketches, you have to be an expert engineer. From the calculation, you have to decide which kind of reinforcement, diameter, and lengths you put in. So this is a very interesting and expert work. You can see sketches. Usually, we design, we draw hand by hand, and afterwards you design by AutoCAD, and this is the image you translate to the draftments. This is the reinforcement, transversal reinforcement with a few areas, different areas of transversal reinforcement for shear. Started bars, because I think this is a slab of the foundation, and details, and more sketches to be drafted. The slab sketches, internal walls, everything is drafted before to be drafted in a final plan. Column, the detail of the columns really, for me, is really hard. Beams, and okay, this is the final step of one design, the RC drawings. After the sketches, we design with SOFiCAD. We design the final drawings to be given for the client. So there is the final level of detailing we have in the drawings for the Doha Metro. I'm going now to change this is our experience, working with BIM, working with other clients, working with SOFiCAD, working with SOFiSTiK. And now I'm going to explain some matters related with specifically SOFiSTiK, our experience with SOFiSTiK for more than 15 years. Why we use SOFiSTiK, a list of SOFiSTiK projects we will see, building works, civil works, and Airlock Towers. And 2D versus 3D, I used to say that it's important to have an accurate model to discover special things with 2D is not easy to see. And interesting facts about Doha, or examples or things we have thought modelizing in 3D the metro stations. Why SOFiSTiK? Because it's a skilled program focused on civil works, on building works, because they have a very interesting graphic interface, AutoCAD. It's easier. It's easy to import files. And regarding post-process, we have a very powerful static data output, Ursula. For the dynamic data, the wind graph is very useful for us to see the efforts to turn the structure, to see every kind of efforts in every kind of views. You can imagine the structure. This is a programmable and measurable data output. Also, in the dynamic data output, the animator is very interesting to know how the structure is moving. You can export full reports for the client, for the final client. It's very interesting that it's 10% parametric, 100% parametric. For us, it's very important to work with parametric models to change several things in a few period of time. And the ECCD is used for simple projects without need to change any line of code. Without write code, you can use SOFiSTiK. And also you can use several modules, so you can use one thing for CFD or for other kind of, for pre-stress structures or anything. Here, one review of things you realize when you made 3D models instead to do 2D models simplifications. For example, the abutment is one of that examples. If you don't have 3D models, you forget and you lose some data, some results. You have to know only if you have 3D models. Or the impact loads, the effect of one load, impacting load. It's very important to have also 3D models. Or for example, in a long structure under the ground, you have a lot of length. If you are studying the structure with transversal cuts, you can see that kind of effects, for example, because you have not a square, you have a tube. Other important things is, for example, the level of the interaction between a beam with a big depth into a wall. If you make an approach, simply approach, you can support this beam with a fixed end in the wall, but you cannot be able to study which is the real behavior of that kind of efforts. So you have to design the real depth of the support to know which are the efforts between the wall and the beam and the wall. And you have to put that kind of elements to understand which is going on in that structure, because the joint between the beam and the wall. Or for example, the consideration of nonlinear support in a slab foundation with compression and no tension. If you make a normal spring in that kind of support, you have wrong results. You have to discover there are wide areas without tension, and it's only possible with nonlinear modulus reaction, subgrade reaction modulus in your model. Or other kind of things are the different subgrade reaction modulus you can enter in your model. For example, in this structure in Doha, we have a lot of different kinds of subgrade reaction modulus, and the effect in transversal section like that and in longitudinal sections are very important to know the real behavior of the structure together. Okay, and finally, I'm going to show you an overview of some of our projects in civil and building works. This is Arinaga Bridge in Tenerife, Iceland. This is the footbridge, and into the two lines of footbridge there is a bridge, concrete bridge. This is an example of metallic staircase in a building in Madrid, a new staircase of an old ancient building. This is the Cali Airport in Colombia, an airport finger with a extremely high seismic action. Water treatment plants, this is in Argentina. Arrazola Bridge, this is a very long bridge with a box concrete girder. Or box concrete girder also in Cambrils. Cambridge is not Cambridge, it's Cambrils, it's in Tarragona near Barcelona. With post-tension structure, typical. Lomo de Ratón Bridge with the post-tension you can see there. It's a viewpoint in Tenerife, in Canary Islands. It's an architectural shape for a point is used to see the landscape of Tenerife. Post-tension slabs, for example, this is the university in Sevilla. Switzerland, bridges in Switzerland with curves, geometries. This is the research in precast panels to be cantilevered in a provisional way. This is an example of an airlock tower. We have made a lot of airlock towers with conical shape. It's conical, it's not polygonal. It's conical shape with external post-tension. And finally, 120 meters high, you can see on the right side of the slide. And this is the final construction of that tower, one prototype, and afterwards 120 towers we have built in Brazil and in Finland. Concrete towers, 120 meters with precast dowels and put with very experts, workers, as you can see, mounting in a horse. Structures of buildings like this amazing house near Madrid, a TV house. This is a SOFiSTiK model. This is a strange house for one family. This is the final image of the house. We have built also. We have used SOFiSTiK to do roofs in concrete, thin roofs in concrete in very high seismic areas. That is in Santo Domingo, in Central America. This is one structure from Moneo. Moneo is a very famous architect in Spain. It's Pritzker. He won the Pritzker Prize a few years ago. And this year, yesterday, one of the Spanish team of architects has won the Pritzker Prize, RCR. This is in Santo Domingo. It's an existing church. You can see the existing walls in stones, with the stones, and the new structure. This is all the strange family house. This is a car collector. You cannot see the length of the house here, but I can tell you that this house has a parking lot for 120 cars. It's really amazing house. This is one structure. The old structure is in the main street. The main street in the city in Madrid is the first level you can see at the right side, and afterwards the architect wants to high-rise the building with a wall, and we have to do some wind investigation about the behavior of the increasing of height with CFD and also with wind tunnel. This is a textile structure. This is a structure from Calatrava, a very famous Spanish architect. It's a strange thing too. It's 60 meters in cantilever, metallic pieces, I don't know, it's a strange structure. This is the real structure built. We have participated in that structure, making a report about the behavior of the roof. You can see the building at the left and right. There is an elevated building. It's part of the ensemble. We have participated also in Guggenheim, in Doha Museum, Doha Guggenheim Museum, Abu Dhabi Guggenheim Museum. This is a part of the full structure, and this is another part of the structure, and this is the final image of the structure. We participate here in the tender part. And finally, this is Alcantara Bridge. This is in tender phase. I would like to win this concourse, this race to be the designers of that bridge. Alcantara Bridge is very famous in Spain because they have. This is our idea. It's very famous because to do that kind of this is the Roman bridge, most ancient Roman bridge with 80 meters length and 50 meters high. It's a Roman heritage in Spain, in Extremadura, near Portugal. It's the Tajo River, that's one. I am that guy. And we are going to see the landscape before design that idea. And this is the bridge, the Roman bridge, I tell you. And with that, I finish my intervention. Thank you very much.
Спасибо, на самом деле было очень интересно.
Thank you. It was very interesting and some geographical insight also. Do you have any questions to our speaker? If you have any, please raise your hand, because it's a very rare chance. There is one question, please. Please use the microphone. We need a microphone. Please give it to the person asking questions. How did you building structure and soil interaction in a metro station? Which module did you use for those purposes?
We use when you design with subgrade reaction modulus, you have to be sure the choice of the modulus is good, and you are not sure never. No, it's very difficult to assure the behavior in terms of coefficient of subgrade reaction, because the real thing you would like to know is the modulus of elasticity, but most of times you have not that number of modulus of elasticity, and you have the spring coefficient. No? So how the spring coefficient is not sure, you have to prove with one coefficient and the double or 3 times that coefficient. In that project, we tried with the geotechnical information, we tried with 3,000 tons per cubic meter, and we tried to with 1,000 and with 10,000 to be sure the behavior of the structure is good. So we have to try with an interval very big, because the subgradation modulus is a strategy, it's not true, it's false, but it's useful because it's easy to implement in the calculations. Here we could to implement the elastic modulus of the soil, but we hadn't that result of the geotechnical reports. It's a very interesting
the question was about module, not modulus. Sergey Glaskov, MOS Project 3, Juan Carlos, thank you very much for your presentation of impressive experience of using SOFiSTiK. And my question to you is it possible to connect to your experts and have a consultation, consult them about some engineering problems? Because I see that we have some similar engineering problems. We asked the developers for them, can we have your contacts or contacts of people who made the analysis for curved bridges, and so that we can exchange experience and can discuss technical questions. Is it possible? And how can we get the contacts after the conference? I can approach you after the conference, or shall I write to you and you can relay us to your colleagues? Thank you so much.
Момент. Ответили? Получили ответ, да?
Did you receive a question? Yes. And are there any other questions? And now I will use my position as chairman. And will the Roman bridge be demolished or refurbished, or what's going to happen to the Roman bridge in Spain?
Is working. In the Roman bridge is working now for the cars, but the capacity of the street of the road is not enough. So they are designing another road parallel to the existing road, and they have to cross the river by other way, no? More or less where the plane is. Above the plane. Below the plane.
Еще один маленький вопрос. Откуда у вас такой большой...
And my question is, how come that you have such large experience in designing metro stations? As far as I know, 400 Spanish designers and engineers participated in designing Moscow metro stations. So how come Spanish designers have such a vast experience with metro stations?
We made a lot of metro works in Spain, train stations, a lot of kilometers of metro in Spain, a lot of kilometers of railway in Spain. We have a very huge chain of railways and metro stations. And afterwards, with the crisis in Spain, everybody is going out to look for works, and in Moscow, in Doha, in Mexico, in everywhere. There are a lot of civil engineers in Spain because we were lucky to be able to build a lot of things in Spain and to learn a lot in that kind of especially, for example, in Spain, we made a lot of special bridges. So there are a lot of civil engineers in Spain. They have in his curricula, they have suspension bridges. This is not easy to design, but fortunately in Spain we had that opportunity.
Спасибо. Есть еще вопрос?
Thank you. Any other questions? No more questions in this case. Thank you very much, Juan Carlos, and we wish you all the success possible.